It was a holy moment. The Andromeda Nebula overnight became the Andromeda Galaxy. For years, our understanding of the Andromeda Galaxy was limited to ground-based observations. However, with advancements in technology and the birth of the James Webb Space Telescope, our understanding has grown beyond measure. Now things are about to change as the James Webb Space Telescope has detected alarming signals coming from the Andromeda Galaxy. These signals have sent shock waves through the scientific community, leaving astronomers both inspired and curious. But what exactly do these signals mean? Most importantly, why are they causing such a stir among astronomers? Join us as just 2 minutes ago the James Webb Telescope shut down after receiving alarming signals from the Andromeda Galaxy. Before we could see far beyond our eyes into the cosmos, astronomers believed the Milky Way to be the whole universe. This lack of insight was primarily due to limited technology for seeing various galaxies and individual stars. However, everything changed when we discovered the Andromeda Galaxy. It served as our first hint to knowing that the universe stretches far beyond the Milky Way. In human imagination, it all began in the 17th century when Galileo's pioneering work with telescopes revealed the Milky Way's true nature. He saw that the Milky Way had numerous stars, challenging the prevailing idea of its singular importance. Everything changed in the 1920s when Edwin Hubble discovered distant objects beyond the Milky Way. Using the Hooker telescope, Edwin noticed that these celestial objects moving through the cosmos were galaxies different from the Milky Way. One of the galaxies was the Andromeda Galaxy, or M31. While this was the first time we were seeing the Andromeda Galaxy through a telescope, Persian astronomer Abd Alaman al-Sufi first noted it around the 10th century. Thanks to the technological advancements in the 20th century, astronomers could see and understand the true nature and essence of Andromeda. Andromeda is a nebulous cloud consisting of a vast galaxy of stars. Similar to our Milky Way, our cosmic neighbor is approximately 2.5 million light-years away from the Milky Way. Since its discovery, the way we study Andromeda has profoundly evolved. We have moved from ground-based observations through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Each advancement in technology has taken us to new heights, helping us understand the secrets of the Andromeda Galaxy. We now have more information and insight into its composition and structure, making Andromeda a benchmark for studying the formation and growth of galaxies. This has shed more light on the broader working principles of the universe. Scientists believe that to have a better understanding of our universe and the Milky Way, we must study the relationship between Andromeda and the Milky Way, especially given that both galaxies are bound to collide in approximately 4 billion years. While studies and investigations have progressed, the James Webb Telescope recently received a concerning signal from Andromeda. This alarming signal baffles scientists worldwide, prompting questions about its exact origin and potential implications. The James Webb Telescope's advanced sensors have detected unusual activity right inside Andromeda's core. The signal sent back to scientists shows results that significantly differ from past observations, intriguing scientists worldwide. The signal indicates major processes going on within the galaxy, potentially linked to its supermassive black hole or previously undiscovered occurrences. Notably, one of the latest findings indicates that Andromeda's mass may be much bigger than that of the Milky Way, reshaping our understanding of both galaxies' sizes. The James Webb Telescope has also provided detailed images and spectra of Andromeda, unveiling the formation of new stars and their chemical compositions. This new data is important for understanding galactic evolution and potential conditions for life. Additionally, the data from the telescope suggests increased activity in Andromeda's active galactic nucleus, ultimately impacting its surrounding environment and shaping its future structure. Furthermore, by looking into the gravitational effects on stars within Andromeda, researchers gain insights into the distribution of mysterious dark matter throughout the galaxy, hopefully furthering our understanding of its influence on the dynamics at play in the cosmos. As things are understanding dark matter and its impact on the universe is one of astronomy's greatest puzzles. Recent breakthroughs by the James Webb Telescope have motivated various studies worldwide as scientists look into the secrets of Andromeda. With more information coming to light, we now know more about the galaxy's past and future. So what have we learned about the Andromeda Galaxy through various studies? Andr has shown impressive characteristics that distinguish it from other galaxies spread across the universe. Its sheer size commands attention, with recent assessments suggesting a diameter spanning around 220,000 light-years. This figure makes it one of the largest galaxies in the local group, even bigger than the Milky Way. This vast scale contributes to its mass, consisting of an estimated trillion stars, surpassing our galaxy in stellar count. Researchers also find the GST structure fascinating. Unlike a typical spiral galaxy, Andromeda has a bulging center and a dense nucleus enclosed within rings of dust and gas. This is undoubtedly a fertile ground for ongoing star formation, such features showing a dynamic galaxy created by continual processes shaping its evolution. Among its many features, one of particular interest is its nucleus, characterized by a double peak commission, hinting at the presence of a supermassive black hole similar to but different from the Milky Way's. This offers important insights into the nature and activities of these massive matter-eating holes. Andromeda is also encircled by a sphere of stellar debris, consisting of stars, planetary and globular clusters spanning hundreds of thousands of light-years in diameter. This cosmic covering tells a captivating, detailed story of the galaxy's unique origin and history. The 460 globular clusters found in Andromeda also offer insight into the formation of stars in the very early stage, providing a clear explanation of the formation of star clusters and the early development of the galaxy. In piecing together the mysteries of Andromeda, astronomers are one step closer to understanding the cosmic relevance of dark matter. However, one question lingers: how do they account for its mysterious nature and the role it plays in the dynamics of galaxies? Andromeda boasts another distinctive feature: its satellite galaxies. Its halo structure is made up of more than 20 smaller galaxies, and some of them are under tidal stripping of their stars and gas. This process involves a larger galaxy pulling in and destroying neighboring small galaxies, displaying the active nature of cosmic evolution and portraying how galaxies grow and interact with each other over time. So what does the future hold for the Andromeda Galaxy? The shape and direction of its movement fascinate not only astronomers but also those seeking to understand the cosmos. The possibility of its transition from a spiral to a ring galaxy is centrally strategic in Andromeda's development. Evidence points to a process that could lead to other rare combinations, possibly from galactic collisions or close interactions with other galaxies. If Andromeda is indeed moving in this direction, it means that it has experienced many interactions with other galaxies since its birth. Ultimately, Andromeda's future depends on the imminent collision with the Milky Way. According to these models, the collision is estimated to occur roughly 4 billion years from now. The result of such a collision is the birth of a new galaxy. From these two giant celestial entities, though destructive, the collision is a natural part of galactic development. However, due to the vast distances between the galaxies, this galactic collision isn't a direct impact. After the collision, both galaxies would be radically restructured, forming new shapes and compositions. The interaction of their gases and dust will stir up new rounds of star creation, leading to a large spectacle in the sky as the merging objects twinkle brightly. Such a cosmic event will result in the formation of a single elliptical galaxy. This type of collision isn't unique, as the universe has a long history of such events. However, our direct participation is what makes it an event of interest to us. In addition, the predicted collision of the supermassive black holes at the nucleus of the two galaxies adds more secret to this divine show, recommending an intricate and profound nature of enormous advancement. The consolidation is anticipated to create blasts from issue being overwhelmed by the dark opening, which will deliver broad radiation. This cycle offers significant information about how worlds move all through their life expectancy and how dark openings influence this development. Anyway, it raises a pivotal question: what will happen to our sun-based framework after this consolidation is shaped? Far from a complete obliteration of the sun-based framework, the planetary group's direction and conditions could be changed. Essentially, this infers conceivable circle moves or even discharge from the recently arose cosmic system. To figure out this instrument, researchers can study the size of comparative occasions occurring. Also, contextualize the inevitable destiny of our own universe. It is critical to comprehend that a crash between stars is an uncommon occasion in space on the grounds that of the immense intergalactic distance. Anyway, the gravitational change could upset stars' stable circles, causing a few stars, including our sun, to change direction. Such a change radically upset the environment on Earth. One of the most basic changes people can experience is moving further away or nearer to the sun. This could prompt either warming or cooling impacts. A hotter environment could make ice covers soften. What's more, ocean levels ascend, while a colder one would prompt another type of ice age. On top of that, the math of such an arrangement could slow down radiation levels coming to the Earth, making significantly more testing conditions. Fundamentally, the consolidation of the Andromeda and Smoothway frameworks delineates the complex connection between heavenly bodies. As the dark openings in the two cosmic systems get closer over the long haul, their gravitational activities might build the progression of high-energy particles that can arrive at Earth, at last causing upgraded infinite radiation to infiltrate our environment. The likely flood in radiation levels could be a danger to environments on our planet, as it might increment change rates in populaces and influence biodiversity. The reallocation of Earth's natal circle or its hub, which would follow from the dark opening consolidation, can be anticipated to slow down the way living spaces are spread. How organic entities will get by in environment zones that may become horrible is one of the impacts of environmental change experienced universally. Through shifts in biodiversity and environment structures, albeit a couple of animal types may thrive under the new conditions. Some would cease to exist and others would be exceptionally jeopardized. The consolidation will probably lead to the formation of new stars as mists of gas from the cloud meet up and get packed, assuming that this interaction happens close to our planetary group. Radiation from these adolescent stars could modify the climate, coming about in an extraordinary change in the environment and the whole biological system. While the facts confirm that these occasions characterize the great story of infinite advancement. It means quite a bit to put them in setting and comprehend the timetable. The subsequent occasions of the crash are far away, billions of years into the future, where humankind might have changed altogether. We may currently be living in various pieces of the system or past it. The information got from investigating the Andromeda world shows up to be the way to understanding the advancement of our own universe and its future. The apparent contrasts between Andromeda and our cosmic system can be utilized to foster more exact models for cosmic elements and advancement. The reassessment of Andromeda's size and mass is a strong try, since it straightforwardly illuminates our comprehension of the smooth way and its structure. Subsequently, it has broken our underlying suppositions about Andromeda. Also, the need to re-examine its importance in our cosmic neighborhood. Late information proposes that both the smooth way and Andromeda systems are similar in size rather than our own being a lot greater. This goes against how we might interpret the smooth way's job inside the nearby gathering of cosmic systems and how much gravitational power such a cosmic system applies. While the smooth way today shows up as a band-winding system, its construction could change because of its cooperation with the Andromeda universe and association. That will definitely occur in the not-so-distant future. As such, noticing Andromeda's advancement helps in profiling the components behind the significant world changes by looking at Andromeda's present status and assessing the direction of the ensuing impact on the smooth way. Much can be construed. Cosmologists would show the conceivable changes in star arrangement rate and the conveyance of gas and residue. Furthermore, to the progressions in the two worlds CES, making the model is potential on account of the mechanical Eichel progressions in stargazing that have emphatically changed the extent of room. Concentrates on this has made every undertaking more noteworthy than the past one. The venture started with the development of the telescope in the mid-17th 100 years, which drove space experts to see the circles of moons around Jupiter and the stages of Venus. Gradually, telescopes turned out to be more refined. The late 19th and early 20th hundreds of years saw the plan of more huge and mightier telescopes. The world past the Earth turned out to be more open, while cosmologists revealed new heavenly bodies like Neptune. However, the ground-based telescopes confronted snags, for example, air and light contamination. They figured out how to give amazing experiences into the secrets of the universe with the presentation of the Hubble Space Telescope in 1990. We made a striking forward-moving step in space investigation, in addition to the fact that Hubble allowed us to see the universe from a point further over Earth's environment. However, it likewise almost dispensed with Earth's unsettling influence spreading view. This brought about greater clearness, profundity, and perceptions than at any other time. The Hubble helped a superior comprehension of dark openings, the universe's age, and the current extension of room. The Hubble Space Telescope was joined by the Chandra X-beam Observatory, the Spitzer Space Telescope, and another space telescopes, which further added to our insight about the universe. They noticed the universe from space, bypassing the deterrence experienced on Earth separated from light. Telescopes, radio, infrared, and X-beam observatories have additionally enormously extended the stargazer choices of sky perception with these gadgets. Stargazers are not just ready to recognize, yet additionally concentrate on numerous sorts of peculiarities. This incorporates the universe's microwave, foundation radiation, star arrangement, areas, and the leftovers of cosmic explosion blasts. Anyway, dim matter is still one of the most strange yet fascinating elements that researchers are attempting to comprehend. It possesses about 90% of a system's mass, while being imperceptible common of dim matter is the way that it can't be recognized. Utilizing standard discovery implies dissimilar to other galactic articles that are seen. Dull matter is recognized just through its gravitational impacts on apparent articles' radiation and the enormous scope design of the universe in the Andromeda observational information. Dim matter begins from the system's rotational elements. Stars in its edges show rotational velocities equivalent to those at the middle, which is in opposition to the expectations of prior speculations. This infers that few concealed components credited to dim matter are encompassing and impacting the universe. Notwithstanding the Andromeda perceptions plainly, there is a huge measure of dull matter in the radiance that stretches out a long ways past the noticeable stars through the gravitational field. Andromeda's radiance has a critical effect on the movements of satellites, universes, and star groups that pivot around Andromeda. Through the examination of orbital development, stargazers had the option to recognize how much dull matter is conveyed in a system. Such studies illuminate us that the dim matter corona of Andromeda isn't just huge, however similarly outstretched, including a million light-year sweep from its center. Also, the design of dim matter in Andromeda isn't standard. The mass is focused near the cosmic center while getting more scattered outwards. This dissemination changes the arrangement and advancement of stars, with the gas mists all through the world, making more twisting arms and changing the rate and area of new star arrangement. Other than that, dull matter is conjectured to have gone about as the primary force during the consolidating and crashes of worlds, molding the last types of these infinite occasions accordingly. Finding the mysteries of dull matter is a fundamental journey in present-day astronomy. It is normal to clear the way for significant understandings as to pith and the advancement of the universe. The looming crash among Andromeda and the smooth way is not only a vast consolidation of two universes, yet additionally a collaboration of their huge dull matter coronas. These concealed radiances wrapping both cosmic systems will be moved into the development of the crash and will be fundamental in how the post-combined world will look. The perceptions of Andromeda assisted researchers with filling the holes in figuring out the development and advancement of worlds when the universe was in its earliest stages. Through cautious, profound examination of their construction, space experts basically uncover the little cycle processes that bring forth worlds. Furthermore, transform them north of billions of years. These cycles include the introduction of the twisting arms and the development of a focal lump, which ordinarily happen after sets of cosmic systems coast and combine. This figuring out makes a difference cosmologists to change cosmic models that are proper for the universe. Signals from Andromeda additionally contribute to working on the precision of the infinite distance stepping stool through the correlation of the relative spatial circulations of the close-by stars and the more extensive universe. The exactness of strategies assessing the size of the universe can be further developed. This alignment is basic as it makes sense of essential cosmological boundaries like the Hubble steady, which is use